Hey guys, so in this video I will do a breakdown of the small tool I have made for an upcoming project, and this tool is a max generator, as you can see on the screen, and let me show you what it does. So I can extrude bottom, I can generate UVs. This is not an ideal UVs, this is a subject of change. I can generate low poly mesh out of it. I can control mag radius, length, subdivision amount. I can control the max shape using this profile. I can do all sorts of deformation. And the mag handle will try its best to be on the surface of beyond the deformed surface. I can also it can also do a bottom beveling. It can also change the position of the handle. And as you can see right now, the mag handle is kind of jagged. It has jagged edges, and I can just subdivide it, and it's basically gone. This is not ideal, this is two separate geometries, but bevel could be, not bevel, boolean could be used here. But I have decided to use two different geometries just for the sake of flexibility. And in my case, in my project, this geometry won't be used in any interactive way. It just will be on the background somewhere. So this is the settings, and let me actually walk through how I made it. So this is a mag shape itself, and this is the handle. And this is generating low poly, UVLayout, and this is creating a collision geometry for the Unreal Engine. And that's pretty much it. So the mag shape starts with a simple line, and everything here is by default, except I have changed the direction from default Y to Z direction. And the reason is because here I'm creating a shape using chain ramp. This is a simple wax expression. You can also use a sweep node instead, but I have decided to use a simple wax. And the way I have done it is, so I change the direction of the line, and then I'm doing a resample. And here I have quite a few points, and the reason is because when I will be doing a channel ramp, I need quite a few points to maintain the shape I wanted and to be as smooth as possible. And this is why I have made it. And here in the channel ramp, I named it a mag shape, and I'm using values from this attribute, which I have exported from the resample node. You can export it because, as you can see, if I disable it, it won't work. And here I have an channel reference, channel ramp, and then I revolving the shape, so I can change. So this is how it changes. I'm not sure what to tell exactly about this channel ramp. You just have to play around with it until you get something that looks good to you. And then I'm doing a polyfill, and the reason is because when revolve can produce end caps, but I wanted a triangle fan instead, which polyfill does. Under the fill mode, you can enable triangle fan. And here I have also exported a page group, which I will be using just in a moment. And here exactly where I will be using it. So here in the poly bevel, I'm referencing this page group by right-clicking, copy parameter, and here paste relative reference. And here I can basically control the bevel amount on the bottom edge, this one. And here I created a group for the bottom face, and this group is for creating this bottom extrusion. This is what this part is about. So yeah, under the group node, I'm using an option here by normals. I have disabled base group option, and basically I have changed. This is default values, so I changed the direction to -1 because I want to select the bottom face, which is exactly in the negative y direction. This is why -1 is here is used, and the spread angle is I set to 1 because I just want to select the flat face only, the bottom face only, because so you can just see what it does. Or I could keep it on 0, but yeah. And then I'm using this group, which is group bottom face. And here I have specified $S, which stands for whatever name I have passed here. So it will pick the node, this node name. So if I type here, the group name will be changed accordingly. As you can see here. So here I'm also copy parameter, paste relative reference, and this node, this extrude node controls the bottom extrusion, and the bevel node controls the bevel of this extrusion. And here under the poly extrude, I have exported the front group. I have renamed it because by default it was like so. I have renamed it to make more sense for me. And then again, copy parameter, paste relative reference, and under the bevel node I have enabled ignore flat edges because by default it was like so, and I only need to select outer edge. I hope this is how it's called. So if I enable it, and as you can see, I have just increased this value a little bit. And then I'm offsetting the distance of the bevel. And one thing to keep in mind is I have changed this value and this value because it can go like so, and it will possibly ruin the geometry. And I wanted to bevel to the maximum amount possible until bevel hits another edge. So as you can see here, it's like collides with another edge, and it won't go any further. And here I have a switch node, which is enables or disables it, and I have created on the HDA type properties toggle, this one, and that's it. And then I copy parameter, paste relative reference, and then I'm using a bend swap, which in this case it's not for bending. This is to control the length of the mark. And everything here is disabled, and the only thing I have changed is capture length, and I have used the bounding box expression. So basically what it does, it will, by default, it will be like so, and if I change it, it's a very minor difference, but this is to make sure the capture length will be consistent no matter what will happen upstream in the null graph. So it will always capture the entire length of the mark. And you can check out what bounding box does. But in this case, I want to make sure that capture length will be equal to the length of the mark. And then I'm doing creating another switch to generate UVs, and here I have auto UV by labs, and the method I have set to unwrap. And this is what UVs I get. It's not ideal. I will come back to this later, but and then I'm subdividing geometry, and the reason is because I will be doing deformation using bend in this case, bend and taper, because if I don't have enough topology, the bending will be jagged sometimes, and Mach handle won't always be exactly precise of its location, and this is because of the bending. Yeah. So here, everything here is by default, and almost by default. So I have changed the up vector, and I just clicked on the B, so I can cycle the direction, and the up vector is set. I have set it to 90 to bend in this direction. And the taper, here is everything by default. And here I have also added the expression, bounding box expression, to capture the entire length of the mark from the upstream modifications. And the bottom taper is basically the same thing as in this top bend node, but here I have reversed the tapering to taper on the bottom of the mark. And after that, I'm creating an Unreal material, which I will be referencing directly in Unreal. And here I have deleted the curve U attribute. And what about mark handle? The mark handle was created using two grids. So this is one grid, this is the second grid, but it actually looks the same right now. But here I have a transform sub, which basically moves top part of the handle. Let me actually show you. So here I created under all the bending and deformation, I have created a null node to reference it in this transform sub. Here I'm also using a bounding box expression, but in this case I'm referencing. First of all, I'm referencing the null node, which I called outshape, and then I'm using a dymax. Dymax means that it will move this grid to the maximum of the y maximum of the mark, so basically to the top of the mark. But here I have also created a simple parameter. So I clicked on the edit parameter interface, and then I have added a float, and then I changed naming to this, basically. And that's it. And I hit accept. I will delete it. And then I have this parameter available. And then I copy parameter and paste relative reference. So here I'm negating this value, so I can control where the top portion of the handle, or whatever it's called, will be placed. And under the Z, I have also used the bounding box expression, but instead of dymax, here I have used the dzmax. But if I change it to zymin, dzmin, those namings are funny, it will go in the other direction. So in this case, I need a max. And I have also changed the uniform scaling here. And the same goes for the bottom part of the handle, but it's in the bottom. And I have also added a channel reference here. Parameter, which I have also used in the Y value, but instead of negating, I have adding this value to whatever value returns by the bounding box expression. And that's it, pretty much it for the handling part. And after that, I'm subdividing this grid to get enough topology. And oops, mispronounce the shape. And so I subdivided it. And the reason I need subdividing it is to get more topology to be used by the ray SOP, which projects this grid. We actually disable it. so it's needed for the ray swap to project this grid onto the deformed mark shape, and if grid won't have enough topology, the edges will be jagged, and grid won't be laying on top of the mark geometry very nicely, if it makes sense. So if I change, it's actually hard to see right now, but so as you can see, like this edge right next to the middle edge, it's not it's not deforming nicely along the mark geometry, but if I increase the subdivision amount, you can see the difference here. This is what I'm trying to basically explain, why I have subdivided this geometry. And so the ray swap is used to ray grid on top of the mark geometry, and it will try its best no matter how deformed the mark would be. And the only thing I have changed is not actually, I haven't changed anything here. Everything here is by default. So and under the second input, which is a collision primitive, I have also using an object merge and referencing the out shape null, which you can see here. And then I'm creating a group, which is a whole grid. Everything here by default. I have also changed to the $s. This will mean that whatever I have typed here, will be a group name. So I have a group name which I called start. So this will be a start of the handle. And the same goes for the bottom part of the handle. I also subdividing it, rain on top of the geometry, creating a group, and then I'm merging everything together. And here I'm using a bridge, which creates this handle. Under the grouping, so you have a source group and this destination group. And for the source group, I have used the start group, copy parameter, place relative reference. For the end group, the same thing. And basically, I have exposed, and also by default, it will be like so. And if it's like so, you need to change the spine shape to the curved, in this case. And for the magnitude stiffness, reverse widening, depart options, and you have just to play around with it, with these options. And the reason I have needed a reverse winding is because I think it's because here the face is reversed. If I reverse it like it should be, here is also the same thing. Let me actually double check if it's the case. So right now it's reversed, but now so you just need to play around with it, because I kind of expect the different thing to be happen. But so I have play around with the reverse winding and arrive and depart options. By default it was like so, or something like that, or like this. So if something is doesn't look as expected, just play around with these options. And the magnitude was this, control this. And as I said, I have exposed all of these parameters to the HDA level, which is these options right here. And these options comes from pretty much all of the options comes from the bridge swap. And then I'm creating UVs for the handle, subdividing it, and then creating a Unreal material for the handle. And after that, I'm merging everything together, doing a UV layout. This switch is for creating or not creating UVs. Then I'm fusing everything together. I had some, as you can see, I guess, let me actually show you. So some of the points are overlapping here, as you can see. So this fuse is to merge those closed points. And then I'm creating a low poly by using a switch to create or don't create a low poly. and I have exposed this keep percentage to keep option to the HDR level. I have checked the preserve quads option because by default it wasn't checked. Then I'm creating normals, creating collision geometry, as I said before. For the Unreal Engine, you can also do the same thing for the Unity. And that's pretty much it for this small tool. Hope it wasn't too confusing or complicated, and if it was complicated or confusing, please write a comment in the comment section. And my patrons will receive a video of me creating this mark from scratch in a step-by-step manner instead of breakdown as I did right now. So yeah, have a great day. See you in the next video. Take care.